So in this recording, we're going to talk about the case that along the balanced growth path, the growth of the technology is given by GA equals to lambda n 1 minus 5. हम ये prove कर रहे हैं. This is what we are going to prove. So this is just using the knowledge which you have developed in the earlier classes of the Romer model. So we are given with this production function v y equals to k to the power alpha a l y to the power 1 minus alpha. A is of course capital. Ly is the labor employed in the production of output. La is the labor employed in the production of research or in research, right? So Ly is the labor employed in production of output, right? And A is the stock of ideas or stock of knowledge. Alpha is the parameter, which is lying between 0 to 1. K dot is Sk, K minus dk. So Sk is the rate of savings. This is d into k, not derivative of k, d into k. D is the rate of depreciation. Population growth rate is also given to you. L dot by L is equal to N. Is the population growth rate. A dot is the number of new ideas which are produced. That is the change in the stock of knowledge. Number of ideas, or is it number of new ideas produced. Number of new ideas produced. And you write A dot as delta bar LA, where delta bar is the rate of discovery of new ideas. Right. LA is the proportion of population which is engaged in research. Ly is the proportion of labor which is engaged in production of output. La is the proportion of population which is engaged in research. Or not proportion, the population engaged in research. Not proportion of population, because it is Ly plus La is the total L. So Ly is the population engaged in the production of output. La is the population engaged in research. Rate of discovery new ideas, which is delta bar, is delta e to the power phi, where delta and phi are constants. Phi greater than 0, it is representing that the productivity of research increases with the stock of ideas. That also is happening, right? So there are stock of ideas which have already been discovered, and with those stock of ideas, then new ideas are developed again. Represents productivity of research increases with stock of ideas. Already been discovered. And phi less than 0 represent the fishing out case. Phi less than 0 would represent fishing out case. That is, with the stock of ideas, now you're not able to develop the new ideas. The productivity of research is falling. So I can write A dot as lambda. This is A dot lambda. Sorry, delta L A to the power lambda A to the power phi. Right. So I'm writing it this particular way. So you have A dot you have written as delta bar LA, delta bar you have written as lambda A to the power phi. And here, no, delta bar you have written as delta A to the power phi. So, and here you're writing LA as LA to the power delta. This LA to the power lambda. This lambda can lie between 0 to 1. It is representing the productivity of labor in terms of the new ideas. Phi is representing the productivity of research in terms of new ideas. This is telling you, lambda is telling you the productivity of labor in terms of new ideas. It represents the productivity of labor in terms of new ideas. So phi is the externality which is associated with standing on shoulders effect. Externalities. Externality. Associated by representing standing on shoulders effect. Standing on shoulders effect. So you are able to see far off because other people have developed the earlier ideas. So that is what the standing on shoulders effect. I've talked about the standing on shoulders uh, yesterday also. मान लीजिए कोई छोटा बच्चा है, वो किसी बड़े के कंधों पे बैठा हुआ है, तो वो दूर तक देख पाता है। वो इसलिए दूर तक देख पा रहा है बिकॉज ही इज सिटिंग ऑन द जाइंट शोल्डर्स, राइट? सो दैट इज व्हाट स्टैंडिंग ऑन शोल्डर्स इफेक्ट इज, कि आप रिसर्च भी अच्छी कर पा रहे हैं, आप और नए नए आयाम ढूंढ रहे हैं रिसर्च में। वो इस वजह से ढूंढ रहे हैं बिकॉज ऑलरेडी लोगों ने डेवलप कर लिया है आइडियाज को, और उन आइडियाज के ऊपर आपने काम करा है। दैट इज व्हाट स्टैंडिंग ऑन शोल्डर्स इफेक्ट इज, राइट? और लैम्डा, एक्सटर्नैलिटी associated, externality associated with lambda is referred to as stepping on toes effect. Stepping on toes effect. Right. So it is like the decreasing returns to the physical resources in the knowledge production function. That is what stepping on toes effect is. The amount of labor involved in research plus the amount of labor involved in the output production is equal to the total labor which is available. So this is the distribution of the total labor force. Right. And the proportion of labor involved in research is, let's say, that is equal to SR. And this is the labor force engaged in research produce new ideas, right? And this is the constant proportion. We have assumed this. So this is the constant proportion of the labor force which is engaged in research. So 1 minus SR is the constant proportion of the labor force which is engaged in the production of output. So constant portion of labor force engaged in production of output, that would be what? 1 minus SR. 1 minus SR. Now the point is that along the balanced growth path, the rate of growth of per capita output, rate of growth of technology, rate of growth of capital labor ratio, that is all same. That is what the balanced growth path is, right? So along a balanced growth path, rate of growth of per capita output G small y rate of growth capital labor ratio G small k and the growth rate of stock of ideas, growth rate of stock of ideas, they are all growing at the same rate. They're all growing at the same rate. Okay. We have written A dot as what? Delta LA to the power lambda A to the power 5, right? And then I can divide both sides by A. Delta LE to the power this, and this thing becomes E to the power 5, 1 minus. You can write this. Of course, this is 5 minus 1, but I will write this as this thing. Delta LA to the power lambda upon A to the power 1 minus 5. I can write like this. And along the balance growth part, GA is constant. So this A dot by A is GA. Along a balance growth path, A dot by A is GA is constant. But you will have this thing as constant only if the rate of growth of numerator and the rate of growth of denominator is same. But this growth rate will be constant if and only if numerator and denominator of grow at the same rate. They grow at the same rate. So what happens is, let me just write this again. So A dot by A is delta LA to the power lambda whole upon A to the power 1 minus 5. Let me take log of both the sides. Log of A dot by A. This is log of delta plus lambda log of LA, right, minus 1 minus 5 log of it, right? So A dot by A is what? GA. And then I take the time log derivative. So what is A dot by A? That is GA. I'm taking time log derivatives. So d log of delta by dt is 0. That is just a constant. So 1 minus 5 A by dt. But GA is a number, that's a constant. So that is, this is going to be equal to 0, right? This is 0 plus lambda. This is what? This is what? 1 upon LA into dLA by dt. That is LA dot by LA. You have, I mean, while doing growth theory, you should know about time log derivatives. I mean, this I think I've taught about this in the first class of solo model. If you have not seen that recording, please see that. And this d log of A by dt is 1 upon A dA by dt. dA by dt is A dot. So it is A dot by A. Right. One thing you have to understand, this is not L dot, LA dot upon LA is not SA. Is not SR. SR is the share of the labor force engaged in the population. That is not the growth rate. So write one line along the balanced growth path. Growth rate of number of researchers. What is L dot A by LA telling you? That is the growth rate of number of researchers. Must be equal to the rate of growth of population. That is LA dot by LA is equal to N. Right. So if the growth rate of the number of researchers is going to be more than the growth rate of the population, then in that case, the number of researchers will be more than the population. And that is absurd. कोई sense ही नहीं है उस बात का. So if it were higher, the number of researchers would eventually exceed the population, which is impossible. So now what can I write? In place of L dot A by, LA dot by LA is, I can write N minus 1 minus 5 and this A dot by A is what GA is, right? And from here, I can write GA as, just taking this thing here. Okay, I'll take it. 1 minus phi GA equals to lambda n, or GA equals to lambda n upon 1 minus phi. Right? So this is what we want to prove. That is the growth rate in the stock of ideas. That is what, or the rate of technological progress, that is equal to lambda n upon 1 minus phi in the balance curve, along the balance curve. That is an idea what we want to show, right? Chaliye, thank you, beta.